Okay, so here we are, the last one. The Internet of Everything. This is our capstone project, which should make it the most interesting of the modules that you do. However, it's really very, very different to what we've been doing in the past. MOOCs is generally we push information at you, you work at your own pace and sit some form of assessment. They're not very interactive. What we'd like for this particular one is actually heading back to a more traditional capstone project structure. So we want to interact with you. We want to have dealings with you. There isn't a huge amount of information on the WebEx portal itself. This is really about you creating and developing your prototype or your business plan, depending on where your expertise lies, and working with some of the other students, if possible, to bring that to fruition. So what we'll be doing is every fortnight we'll present a small topic which is not covered in the IoT MOOC. So we deal with very specific areas such as spatial sciences. If you're doing any geolocation stuff in your IoT, very handy for that. How to bring your product from prototype to commercial production, and a few other topics along those lines. After we give that hopefully fairly short presentation, there'll be time to discuss any issues you're having with your project, what you're actually up to, give us a bit of an update, see if we can help you out in any way on developing that further. So to get started, we'll introduce ourselves. You've seen pictures of us before, I think, but we'll try and get along to all of these sessions. Some of the others will be along as and when needed due to their other teaching commitments. But with us at the moment, we have me, Ian Murray. I'm currently the Deputy Head of School for Electrical Engineering, Computing and Mathematical Sciences, which includes physics. And of course, my expertise is in IoT. We have Yiffy with us this morning, which is great. Yiffy, you want to give yourself a quick intro?
Hi, our name is Yiffy. I'm a researcher fellow at the Curtin Cisco Center for Networks. My background is related to software-defined network, IoT, machine learning.
Thank you, Yiffy. Yiffy is the go-to guy for anything networking, software-defined networking, AI, machine learning, those sort of areas. Savash.
Morning, everyone. So my name is Siavash. I like going after Ian because I can say I'm from the same school as Ian. I don't think a long name. So my area is, of course, IoT with a bit more of a focus on the sensor and the edge devices. I'm also the academic lead for Innovation Central, which is one of the research centers where we do smaller projects in collaboration with industry. So if you ever had any questions on the physical hardware that you're looking at, on the sensors and the microcontrollers, I'll be able to help you out with that. Looking forward to see what projects you have in mind.
Thank you. And those who aren't with us this morning are Hannes. Hannes is a senior lecturer in the same school, and you can contact him regarding anything to do with algorithms, efficiency, any of the mathematical sides of programming, if that's something that's of interest. Valerie is our Python guru, so anything Python, and particularly to do with large data sets, data science, prediction, those sort of areas using Python. She's the go-to person there. And David McMeekin, who is our spatial science software engineer. So anything to do with location-based services or mapping, tracking, those sort of things, David's the go-to guy there. Okay, so if you message us or you need some help with something, use the edX site, or you can also follow up with the email that we've supplied. What is it again, Savash? IoT6x at Curtin?
Yes, I'll post it in the chat shortly. Yeah.
So if you don't hear from us in a couple of days, please email to follow up. We do get an awful lot of emails and things can get lost. Okay. A few ground rules to get started. As I mentioned, these are recorded, so please keep that in mind when you're making comments. Also be polite and respectful to everyone. In the smaller numbers, it's probably not so much of an issue, but if you want to say something at any time, you're most welcome to. Please interrupt. As I said, we want these to be interactive, not us talking at you. We can get that in a video. Raise your hand, which is a selection you can do within WebEx, and we'll ask you to speak as soon as we can. You don't have to run your video, but it's always nice to see who we're talking to. So we like to see your video, but if you can't do it, or there's a bandwidth issue, or you're at 2 o'clock in the morning and you don't feel like dressing up, then fine, not a problem at all. So what we really want to do today is ask you to introduce yourself, who you are, where you're from, what's your idea for the prototype, and if you don't have an idea, well, hopefully we can sort that out this morning. Okay, so again, the purpose of these meetings every fortnight, we really want them to be about you asking us questions. As I said, we'll have a little chat to begin with, a bit of a presentation to get things moving. But it really is about us being available to assist you in the development of your business plan, your prototype, and actually achieving something worthwhile at the end of it. And we have had some really, really good projects come out of this. We've got a couple that are being commercialised with us in Perth that were started as ideas within this this MicroMasters. And again, if something is looking worthwhile from your opinion, we're quite happy to continue to assist in any way that we can. So if you want to take something further after the course has ended, keep in touch and we'll see if we can actually help you out at all. We had a very nice one that was produced in the hot water system monitor. Can you remember which country that was from? Somewhere in South America. Colombia?
I think Colombia, yeah.
Yeah, I think it was Colombia. And he won the National Award for Innovation on that particular one. And it was just a safety system for the very dangerous type of hot water systems they use in his country. And it's a electric water heater that fits on the shower head itself. So you've got electricity feeding directly into the shower head, which is an interesting concept. But the big problem with that one is it didn't have any thermostatic control, so it would burn people as well as electrocute them. And he developed a monitoring system and a control system to keep an eye on that. So with your idea, it always pays to be rather ambitious and creative with it. It's easier to reduce the capabilities down to a set limit and only work on those rather than just only think of something very basic, unless that has a very good market. We'd like you over the next couple of weeks to be thinking about what the requirements are. So what will you need? Do you need to order parts in? What are the requirements from the end user's perspective? And this is really what the first assessment is really about. We want you to think in depth onto why you would develop your device. What purpose does it serve? What problem does it solve? Is it going to be something that is marketable? And we do talk a lot about this, I think in the third session, when we're looking at commercialization. What makes a device worth developing and worth putting into production? It's not necessarily the economic gain from it. That may not be something that is going to give a particularly good return on investment, but it could be something that will assist society in some significant manner. So the philanthropic side is just as important to us anyway as the financial side. But we'll look at that in more detail later. If you could make a list of questions before the next meeting, that'd be great. If not, we can do things on the fly. And I mentioned here a couple of times things about teams. When we had very large classes a couple of years ago, we broke everyone up into teams of related topics. So if you were dealing with something to do with animal health, and we had some really good animal health ones, we'd get all the guys who were working on animal health together as a team, and they would collaborate and help each other out. This time round, we might have a couple of teams that would be useful. I think we've got about 15 to 20 students. So we'll look at whether we should do teams or not after our evening meeting. I think we should know by then. But that's very useful because the peer support that you can get is actually very, very advantageous. Very advantageous on getting an external view, a sounding board to see if your ideas are making sense, get an outside view onto other options that may be available. Just generally to discuss things and reduce frustration when you're at a block, or to get those outside ideas which you may not have thought of. And of course, make some questions for us because, as I said, we don't want to be talking at you for an hour. We would much rather have a discussion. So really, that's all I wanted to cover this week. But we now really should get on to a bit of a discussion about what you guys would like to do, what you want to achieve out of this capstone project. Anything from your experience so far that could be beneficial either to us or to you in developing that. So we'll stop the presentation and I'll stop sharing my screen.
And it would be good, I'll just mention something. It would be good if you tell us a bit about your technical background and
Yep.
how familiar you're from the IoT point of view outside the course. And if there is one of you who prefers to do this project as more of a business case and look at it from more of a designer than implementing the actual technical components of it, that's completely okay as well, because we have people from completely different types of education backgrounds doing the course. So the project you end up choosing, then the topic, you can focus on the requirement and the specifications and the design aspect rather than actually building it. Of course, if you do go down the path of building it, we'll give you some guidance and we can offer some assistance. But if that's of a concern, I just wanted to mention that that's not an issue to do the project from that point of view.
Yes, we've had a very wide range of people. In fact, one of my favourites, we had a vet who specialised in horses, developing a system for monitoring horses and reporting their health. And one of the big issues he had was you can tell a lot of the health of a horse by the colour of its nose mucus. So he's developed a sensor to identify the colour of horse snot. A very useful thing to have, but I thought it was quite creative. Okay, who would like to go first? We're going to have a...
I'll try. I'm Andrea, as I said, I'm from Italy, Torino. I currently work as a software product manager for a company that is in the alarming systems field. I've been a software developer for 15 years, a JavaScript developer. And lately I've been growing my interest towards the IoT field, because out of that, it is something that is going to grow exponentially in the upcoming years, and also fascinated by the opportunity to interact with software, with things. So the opportunity to also delve as a former software developer into the physical architecture of things via software. So it is a very fascinating subject. And I chose to subscribe to the IoT course because I found it to be an extremely interesting opportunity to deepen both the technical aspect and the business aspect of things. By the way, already proposed a sort of sketchy project in the Teams section, and it is about a possible device, ARM device aimed at helping small museums, cultural heritage institutions to somehow protect their collections. It will be a very basic alarm system. One of the main concerns of a curator in a museum is to prevent people from touching the pieces on exhibition. Well, I would like to, if it is possible, to develop a very basic alarm system for mainly for educational purposes. I do not expect to market anything. I do not have the relevant experience to propose a real world idea, but if it is possible, I would like to exploit this occasion to somehow learn more deeply both the technical subject and the business aspect of a possible IoT project. So I already asked for advice, in particular about what kind of technology to implement to create an alarm barrier. I've been thinking about infrared sensors and other types of sensors to basically detect movement and or create a sort of threshold. And I would greatly appreciate any advice on that.
That's actually sounds very interesting, because even if you're working on an alarm system for museums, if I got that correctly, or those sort of environments, the technology you could develop there would be easily transferable to a multitude of other areas, particularly if you start looking at the indoor localization issues. So if we have a display at a certain point, detecting people, say, for example, from their mobile phone, we can get the ID of the phone, we can tell how far away it is. As they approach it, if they come too close, then we could set the alarm off by using their own phone device. That could be tied into the audio descriptions that we have for people getting the guided tours through museums. And next step on from there would be giving directions to the next item of interest. This becomes really interesting when you're dealing with people with disabilities. So not only do you warn them if they're getting too close, or you say, yes, you're allowed to go and touch this, you can give them directions such as walk 5 yards ahead, turn left, turn right, and you're now at this particular display. And then it could give the audio description of that display, so a blind person could enjoy the environment as well. Giving warnings of you're about to approach stairs, so that they know they're not going to go downstairs, or if they're in a wheelchair, they have to find another route, and it can guide them to that route, while still maintaining that that safety aspect and the security aspect of the application. And what would be really nice in this is you could actually do that in stages. So you start off just detecting when people are approaching a certain point. You develop that as part of the sensor, and you can put that up on a nice dashboard for the security people to watch, and they can see everybody moving around the museum and who's doing what and where they are. Also help in case of emergency and evacuations. So I think it's got great scope. So you can start with something nice and simple and achievable, and then build it out. And we can do that through your business plan that we'll be developing. So you have a version 1, version 2.
Mm-hmm. Actually, at first I thought about a very simple prototype via an Arduino and a very basic sensor, but your suggestion of possibly employing mobile devices is very interesting. I did not think about it, and actually reflecting on it, it could be a very viable alternative, and more sophisticated one.
Mm. Yeah, and using the user's own mobile device would actually reduce, the cost of having to have the audio guides for people. You wouldn't have to worry about losing them.
Absolutely.
Mm. Yeah, so I think that's a really good one.
Thanks.
Any suggestions, Sebastian? Yippee?
No, I think you covered it, and as we go along the course, as Ian mentioned, we'll have some mini seminars where we give you some ideas when it comes to sensor selection, so to select your networks and how you can kind of progress the idea forward. So I think it'd be more fun if you have a more ambitious idea from the beginning, and we'll help you kind of push that forward as much as you can, rather than just making something because the implementation of it sounds simple. That way, I think it'll give you a lot more opportunity to go out there and do some research and see what are the possibilities. And hey, if it ends up being that, oh, it's just a design of it, we've only managed to implement a small section of it, I think that's completely okay. I don't want you to worry about that and have that be like restraining yourself. Because one of the most fun things about IoT and when we're solving a problem is you start looking for um, from the sensor point of view, you start looking for what options are out there to see which one you would potentially implement as a part of your solution. And there's all these different types of devices that's out there. With especially recently, I've become very interested in edge processing. We're having the microcontroller do some of that processing rather than relying everything on the cloud. And the cost of those edge processors have become cheap enough that we can do a lot of more interesting things these days, especially in that context of a hospital where patient data is very important and that sort of thing. So it's definitely a very interesting idea.
Yeah, all of that indoor localization, it's a huge area. There's a lot of research going on in that area, lots of different techniques you can use. And it's got huge application across many, many fields. We did one with a hospital trying to locate what we termed assets, and that counted the medical staff, the medical equipment, so that we knew where the cardiac specialist was, where the what they call that thing, the defibrillator was, and we could match that to the patient in an emergency, find the shortest route to get working equipment and medical people over to the area where they're needed. And that's the same sort of technology as you're talking about, because you're looking at, are people approaching an object of interest?
Absolutely. I actually started with a very basic idea because I did not know whether it was required by the capstone exam, the production of a possible prototype. I'm not a tech person in the field of electronics, so I was a bit worried about this possible aspect. If it is not required, a working prototype, then I would like to push my idea forward with a more possible complex and exhaustive example.
Yeah. As we mentioned, we've got people that come in from a huge range of backgrounds. Um, and the aim of the course is to get people who say are not technical able to talk to the engineers in the right language, understand what the capabilities are and what the limitations are, but perhaps not be able to design the system themselves, but be able to talk intelligently to the people who can. And for the engineers, it's understanding the business side of things, which a lot of engineers just have no idea.
Absolutely. Yes, Dan.
I think there's one thing has to be careful about the proposed system is if you're collecting the information from user's phone, you have to let them know. That's like some people may consider like if I give the location information from my phone, it could be a breach of my privacy.
Yeah, that's another very big area of IoT as well. The privacy and security is critically important because we can capture vast amounts of information about people. So we either we have to get their permission first of all to do it, and then we have to be very careful how it's stored so that nobody else can get to it. Or if they do get to it, it's of no use to them. It's de-identified in some way. And again, on your one, that's something you could have a bit of a look at. If you're, say, capturing the MAC addresses of the the phone connection.
Mhm.
You could then translate that to just a randomized number.
Mhm.
Once the person has left the building, you delete the MAC address.
Oh, absolutely. It could be a viable option. Absolutely.
But thinking about something like that is probably fairly important in your design as well.
Absolutely.
Okay, Steve.
So that's a very interesting idea. Never even thought about something like that. So that's pretty cool. So I'm Steve Webster. I'm currently a product manager slash engineer for a worldwide company that manufactures IoT sensors and devices. And right now I'm currently the product manager for our IoT group in North America. So I took this course initially to sort of get a better understanding what IoT was in general, so that I had a better, I guess, footprint on how to present it to our staff locally within our North American operations. But I've found a lot of holes in our portfolio or holes within our IoT group that I feel that we could probably implement or augment our sensor selection as well as our sensor capabilities for our products. So one of the things that we see a lot of within the industrial sector, especially, is temperature humidity sensors for like commercial refrigeration systems, as well as one of our biggest installations, which we've been sort of humming and hawing about because we haven't had a sensor designed specifically for it, is for the pharmaceutical industry, where they move a lot of their uh, refrigerators around and freezers around various floors within their facility, and they're tracking that on a day-to-day basis. But they're basically all they're doing is temperature and humidity measurements. We've done that quite a bit with wireless technology, but it's getting cost prohibitive because of the new technology, and IoT is typically a lower cost alternative in some cases. So my initial design is going to be based off of LoRaWAN network protocol, just because that's I have a little bit more experience as it comes to that, but I have a lot more resources when it comes to getting samples and things like that. My first intention was to build a Python-based Raspberry Pi system to do some prototyping with initially, to get the sensors to start to communicate and get the data, and then decide on how to basically take that data and do something with it. Obviously geolocation is a very large aspect of, especially when we're looking at moving furniture or moving equipment around buildings, becomes very, very important. So that's sort of what I was looking at initially as a starting point. And what the idea is here is to come up with some kind of a design and then present that to our management team in Japan to look at how can we basically commercialize this as a potential sensor going forward for our company.
Okay. That again sounds like a really, really good project to start on. So it's mostly refrigeration equipment that you're thinking of?
Yeah, for now, I'm thinking commercialized industrial. It's got to be rated to -40. It's got to be able to be used inside fairly humid environments in some cases. So the design of that sensor has to be so that it can be used in those environments and it's not going to have issues long term. That's where the challenge has been primarily, is on how do we put it in an environmental condition or format that's going to be basically in an industrial package.
Yeah.
And that's sort of, if I can come up with a prototype, then I can push that to the engineers in Japan to basically then design the more commercialized version of it.
Very interesting, because one of the things I find really good about IoT is you can actually do a lot more than you initially realize. So if you're looking at the temperature, humidity inside the refrigeration device, I assume. You'd probably want to compare that to the outside temperature, humidity. One of the things that you could possibly look at doing is looking at the health of the asset. And this is really important in most industrial systems. So if you put a vibration sensor on an IMU or similar, you could tell how often the motor is, the compressor starting up, how it's shutting down. Is there something in the vibration pattern that may be indicating a potential failure in the future? So it shutters or it's coming on more often than it should. To be able to tell if it's coming on more often than it should, you'd need to know how often the door's being opened. So you see if the door's been opened, and therefore you expect the motor to come on. And using AI machine learning, which you could actually implement on the edge there, you could possibly predict that this one is going to have a compressor failure in 2 months' time.
Sure. Yeah, there's a lot of abilities, and like we have a vibration sensor, we have pressure and temperature IoT LoRaWAN devices already. So implementation, I thought, like, I didn't want to piggyback too much of what we've already developed. That's why I sort of went to a more of a simple controller rather than like we could take it, or I could take it to like a multi-tech LoRaWAN gateway, for example, and decode all the information there. But I figured if the communication goes through from the sensor all the way through the communication to the controller, it just makes it a little bit, I guess, you get a little bit more of a learning curve out of it. And probably the tech in me figures that that's, a little bit more exciting than just the commercialized version. Like to build a business developer or a business planner develop something like that would be fairly, I probably have not a lot of difficulty doing that because that's what I do on a daily basis anyway. So I figured if I sort of pushed myself on the technical side, because I have very little programming experience at all. Like I've done a couple of Python courses and that just to sort of get a better understanding of it, of how to write code. But it sort of pushes me outside of my standard limits of comfort. So that's why I figured if I got a little bit more on the technical side, it would sort of push me outside of the normal boundaries a little bit more. That's why I thought it would be a little more challenging than just doing it.
How about the geolocation? How are you going to work out where the device is?
So on Raspberry Pi, you can buy GPS sensors and piggyback them off of your pressure and humidity sensor. So you basically create a sensor that's got two inputs. One is your temperature and humidity, and then you have another sensor that would be either on the I2 bus, I2S bus, or the other bus, and it would give you your GPS coordinates. So there's two sensors that you can basically piggyback off of. One, it's called a feather stick, which is a LoRaWAN. All it is basically a LoRaWAN communication card, and it just basically sends the sensor data directly to a gateway. So that was my thought on geolocation, was just to use a GPS sensor to do that, and that's what we normally do on all the rest of the devices that we use.
How do you find the accuracy of GPS indoors?
On our sensors, we can get within about 5 meters.
Okay. So that'll give you the right room, basically.
Yeah. So it's relatively accurate. You do have to monitor it because it will, like any kind of wireless device, it does lose its mind every once in a while. So you have to sort of make sure that it is staying where it is. But typically it may just only be a one cycle thing where it may have lost its part of its communication package and then it came back the next cycle. But now normally that's what we've done in the past, just use a GPS. Okay.
It may be worth looking at some other methods which you could actually work with Humana on to try and get a little bit better accuracy.
Okay.
LoRa, I haven't looked at using LoRa for it, but it should still be possible. The triangulation may be possible from other known devices. So you look at the this signal strength I know with Bluetooth you can get the angle of arrival and angle of departure of signals if you're using
Okay.
Bluetooth 5.1 or 5.2, which may be worth doing because you'll have your Raspberry Pi with Bluetooth on it, but I'm not quite
Yes.
sure what version they run on the latest Pis. It may be worth using the Bluetooth just for location, not actually for any
Okay.
other form of communication.
Yeah, definitely is something to consider for sure. Absolutely.
And actually, the LoRa signal is more close to radar signal, so it actually makes sense for its using as location. But the problem is, I don't think anyone has developed the software has the capability to do that yet.
It might be worth you having a look at that, Yuffie, to see if how hard it would be to implement any form of triangulation or location from LoRa.
Yeah, we can look into that.
I know LoRa doesn't have any angle of arrival or anything complex like that.
No, it's
I don't even
fairly
think it
small
has one
packets.
yet. Yeah, it's very good at what it's designed to do. I like LoRa.
Yes, absolutely.
All right. Anyone else got some comments to make or something I'd like to say?
The only question I have, sorry
Go
to
ahead.
interrupt you. Go ahead.
No, go ahead. Go ahead.
I was just going to ask one quick question. I noticed that when I go into the course right now, still it doesn't show that the registration has been completed. On saying that obviously I'm on the call today, but when you go to the IoT, it just says it's still pending your guys' approval.
Oh, is it for the, because I just finished submitting our approvals this morning. Are you
Okay.
talking about the one where you submit your previous pass? Yeah,
Yes.
that's been sorted. So it
Okay.
should be all good.
Okay. No problem. Thanks. Sorry.
No, that's okay. Just double check if you had any further issues. Shoot us an email and we'll sort it out.
Okay. Thank you.
Cool. Well, I was just gonna mention that if what you're working on ends up being kind of part of the IP of the company, and you didn't want to discuss too much of those details as a part of these meetings, that's okay. Like in the past, if and again, we can sign NDAs if you wish, or we can keep the discussions about the details of what you end up implementing outside these meetings.
Okay.
So just want to let you know that that's an option as well.
Yeah, I saw that. Like I said, I'm still working with our legal department to finalize that part of it.
Sure.
I should have an answer hopefully by the end of this week. So
Yeah, because let us know since the
Yeah.
first Canvanizer submission is peer reviewed. So if that's the case, when you submit that submission, rather than you submitting the Canvanizer link there, you put a statement that this project is under NDA, and that means it will go directly to us, and then you can email us the Canvanizer link directly to us rather than posting it there, so we can mark it.
okay, no problem. Like I said, I'll have a chat with our legal department. I have a meeting set up with them by the end of the week, so I'll let you guys know as soon as I know whether or not it's going to be a problem.
No
It's
worries.
something we've done commonly. It's
Yeah.
not a big issue to us at all.
Yeah.
Okay. Well, if there's nothing else, we've finished a little bit early, but once again, thank you for joining us. Hope you're going to enjoy this course. As I said, if I believe it's actually the most interesting of the whole lot, even though there's not a lot of content online, because it does apply pretty much everything we've talked about in the other 5 courses, and you've got the freedom to actually do as much as you want to do. So it can be fun. We find it interesting. How many of these have we done now, Savesh? 4 or 5?
I've lost count.
Yeah, we've done quite a few, and they've
4 or
always
5,
been
yeah.
very interesting.
I was just gonna just remember something. One of I think it was the second one that we did actually led to a journal publication. Um, and I'll share that link in the chat if anyone's interested to see how that project looked. It was with one of the learners was from Iraq at the time, and now she lives in Sweden. And she was interested in tracking head movement of children with cerebral palsy. She had a son who had cerebral palsy and wanted to build a device that can help her kind of get a better understanding of the head movement. So we ended up actually publishing that article, and she built a device, get some data, and I think it was interesting. So I'll post the link. It's an open access journal, so you can have a look. Of course, then this is something. Just wanted to share an example of something she did the design as a part of the course, and then we ended up collaborating with her afterwards to kind of further develop a solution to a point where it turned into a publication, and then she ended up using it to get to the other university and start a research position. Yeah, just a interesting one.
And then there's the other ones we can't talk about because
Yeah.
we've got NDAs on them.
Yeah, it's always tough.
Yeah.
All right then. Well, we'll let Yamana get back to bed. 2 a.m.
Yeah.
Thanks.
And thanks very much, everyone. The recording will be
Yeah,
posted
thank
up sometime very soon. And next fortnight, we shall see you both in the evening, I hope.
Yeah,
Our
sounds good.
Okay.
If you can't make it, let us know. We can always arrange something else.
Okay.
Fine.
Thank you very much.
Thank you.
See ya.
All right. See you.
See you.
Stop the
See you.
recording.